Good morning. Today we will be working on exponential functions. We're going to write equations from a verbal description. We're going to evaluate those functions, and we're going to do domain and range of these exponential functions. So they're gonna all be word problems, okay? So we're gonna write an exponential function that models the description below. A car's value is worth $18,250 and is depreciating every year at the rate of 4.8%. Write an exponential function to model the car's value after t years. So the information it gave us was that the car's value is worth this amount. Keyword depreciating. What does depreciating mean? Is it going to be a growth or is it decay? Is the amount going up or going down? Depreciate means it's going down at a rate of 4.8%. So we know that A is our starting value. So our starting value of this vehicle is going to be that $18,250. My B is the amount of growth or decay. So our B value is either 1 plus or 1 minus. In this case, because it's depreciating, it's going to be 1 minus. Well, it's not 1 minus 4.8. We need to convert 4.8 to a decimal. So what we're going to do is the way to convert it to a decimal is to move this decimal point right here back 2 times. Okay, so we're going to go back twice, put the decimal point, and fill in the missing spot. So it's 0.048. So 1 minus 0.048 is 0.952. So B is 0.952. Now the equation that we use is going to be y equals AB raised to the, we typically use x. In this case, it asks us to use t, so we're going to put a t instead of an x. Okay, so this equation ends up being, it says write a function. So function is f of x equals 18,250 is my starting value. My B value is 0.952 raised to the t years. So that answers our first question. Our next question is find the value after 6 years. So that 6 is going to go in place of t. So 18,250 times 0.952 raised to the 6 years. So what was the value of this car after 6 years? My value at 6 years is $13,585.80. Okay, now we have these questions. It's the key features of this exponential. So domain, we're not going to graph this. I want us to think about it and use some critical thinking. What possible x value can I have? What possible t value? So how many years old could this be, this car? X can be any number that's greater than or equal to 0. Okay, so when you buy a new car, it is 0 years old. But this car can be 1, 2, 3, 4, 5. So when we talked about, if we just have an equation without the real world model, its domain is all real numbers. I can choose any x values. But in this case, I can't choose a negative number. I can't say the car is negative 1 year old. So my number of years old is any number greater than 0. My y-intercept is my a value. So my y-intercept, my starting value, is 0, 18,250. The range. What's the lowest amount of money this car can go? What's the highest amount of money this car can go? Well, my range, the lowest amount is going to be 0, but it's never going to get to 0. Okay, range is y value. What's the most it can equal to? 18,250. Now notice very carefully the signs that we used here. It had to be greater than 0. It's never going to get to 0. But the most it was worth was 18,250. Okay, so we're only working on the first quadrant here, and this is lowest amount and highest amount, but it can be 18,250. What's the asymptote? Well, the asymptote is y equals 0. Remember, it's never going to get to y equals 0. Even in 100 years, the car's not worth 0. Okay? Growth or decay? Well, this was a decay because the car was depreciating. What was the rate of decay? What was the decay factor? 0.952. That number is going to come from after you do the 1 plus or minus. Okay? Now we're actually going to look at it so we can actually discuss all those values again. Here's the graph for it. I know it's a little fuzzy, so the graph started at 18,250, which is right here. Okay? And look at this graph going down, 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 but you see how it's never going to get to 0. This is in 80 years, and the graph is still not at 0 because the graph will never get to 0. And the question it asked was, how much was the car worth at 6 years? So 2, 4, 6. We follow the line going straight up. Where does it touch the graph? Remember our answer was a little bit above 13,000? Here we go. So we would actually be able to look on a graph and figure out how much it was worth. The asymptote that we just talked about, this asymptote is the line that the graph is never going to touch. It's going to get really close there, but it's never going to touch there. And we talked about range. Now, real world situation. So my graph starts right here, okay? My graph is going to get really, really close to 0, but it's never going to get there. So my y values that this graph can be, my y graph can get close to 0, but the highest amount it can be is that 18,250. Okay, this is the only graph we're going to look at, but I did want us to get a visual of what those numbers and what those words meant. So let's do a couple more word problems. A car's value is worth $16,280 and is depreciating every year at a rate of 1.2%. Write an exponential function to model the car's value after t years. So we're going to do the same thing we did in the last one. We were given that the car was worth this much. It was depreciating by this much. And keyword is depreciating, which means this model is also going down. So my A value is 16,280 because that's your starting point. That's where the graph starts. My B value, because it's depreciating, I'm going to do 1 minus. We have to convert 1.2% to a decimal. So move the decimal point back 2 times. What is B worth? B is worth 0.988. To write the exponential function, f of x equals your A multiplied by your B raised to t, because t stands for the number of years. So there's your first answer. The second question says, find the value of the car after 8 years. So in place of t, and I did fix the x to be a t, my function at 8 is equal to, we're going to take our equation, and in place of t, we're going to put 8. My function at 8 years is equal to, that's how much the car is going to be worth after 8 years. It's not really depreciating by a lot. It must be a nice car, okay? Now, what information do we know? My domain. What possible x values can I have? X can be greater than or equal to 0. I can choose any positive number for the number of years it can be. Y-intercept, that's your starting point. So 0, comma, how much was the car worth when you got it? My range, the car is going to get close to $0, but never going to get there. The most the car is worth. Okay. Where is my asymptote? Remember, the graph is going to get close to 0, but never going to get there. Whatever number you plug in for t, 0, 1, 2, 3, 100, whatever number you put in. You can even check the car in 1,000 years. It's never going to get to 0. Is this a growth or decay? It's a decay. What is the factor of decay? It's your B value. Okay. Let's try one more. In 2020, a town's population is 18,000 people, okay? It is increasing at a rate of 3.1% each year. Write a function to model the population after T years. What did they give us? They gave us a starting population. They gave us the percent, and the key word they used this time was it's increasing. So A is 18,000. B, this time, it's not going to be 1 minus because it's not decaying. The population is increasing by 1 plus. Now that 0.31, convert to a decimal. 0.031. So my B value is 1.031. Write a function to model the data. My function of T, because they asked us to use T, is equal to my starting value times my growth or decay value, and this time it's a growth value, of T number of years. The next question says, find the predicted population in 2025. Am I going to plug in a 2025 into X or into T? No. How many years have elapsed? The population in 2020 was 18,000. We're predicting for 2025. So how many years have passed between 2020 and 2025? The answer is 5 years. So my function at 5 years is equal to, we took our equation and plugged a 5 into T. So now we have to use a calculator to say the function at 5 is equal to approximately, now guys, people cannot be a decimal. So we're going to go ahead and round and say approximately that many people. Let's talk about domain. What X values could I have used? I'm going to go ahead and still say that X has to be greater than or equal to 0. I know that we think that what about the year before? Like what about 2019, 2018? I'm not going to assume that it was growing at the same rate. So I'm just going to go ahead and stay in the first quadrant. Y-intercept is my starting value. So it's 0x and it's 18,000 Y. My range. Well, what's the number that this graph started at? The lowest number in this population as of right now is 18,000 people. How high up can it go? Well, it's going up forever. We don't see a stopping point. So I wrote that because I was going to say, less than infinity. Or we can actually just write y is greater than or equal to 18,000. Asymptote. What is this graph never going to get below? Well, the graph is increasing and starting at 18,000. So for the real world data we have here, there's actually not an asymptote. But if we're talking about just the equation in general, we can go ahead and say that the asymptote is y equals 0. Because if we graph this, they are going to give us the graph that goes into the second quadrant. And the graph's never going to get to 0. The asymptote's not going to affect us for this real world situation. Is it a growth or decay? It is a growth. What is my factor of growth that I have? It's my B value. Okay. Thank you guys all for watching this. If this helped you at all with exponential growth and decay, go ahead and give it a thumbs up, subscribe to this channel, and I will be posting more educational videos. Thanks and have a great day.